Hello, my name's Andy Brazier. I'm a risk consultant specialising in process safety and human factors. I'm also a volunteer member of the editorial panel of the Loss Prevention Bulletin. This presentation will give you an introduction to an important but often overlooked concept known as inherent safety. When we see people properly equipped with PPE, we may be reassured that safety is being taken seriously and people are protected from hazards they encounter in their work. Similarly, if rules are displayed and the bookcase is full of procedures, we can see that time and effort has been put into telling people how they can stay safe. In the grand scheme of things, PPE, rules and procedures are quite easy and cheap to provide. But how effective are they? And why are they needed? Equipment that has safety devices attached may give us a similar level of satisfaction. Alarms that warn if limits are exceeded, trip devices that stop the equipment automatically before it fails, interlocks that stop us starting equipment if it is not safe. These devices are an added expense to buy in the first place and require regular maintenance. Otherwise, they won't work when we need them and the equipment becomes unsafe. And with all this, it's quite easy to be reassured, but should you be? The reason we need PPE and other things that we provide for safety are because we're dealing with things that are potentially dangerous. If we lose control of the hazards, people may be harmed. But everything we do to make a system safe can fail. There's the human element where people may fail to wear the correct PPE or not follow the rules. And manufactured items can fail. That includes the PPE and any engineered safety devices that we install. Again, there's the human element with rules and procedures which people may not always follow, but it is actually impossible to write rules and procedures that cover every possible situation. This is where inherent safety comes along. It proposes a different approach. It encourages us to engineer systems so that add-on safety features are not required. That way people are not going to get harmed because they did not wear PPE, because they didn't follow a procedure, or if a safety device fails. In this article that appeared in the LPB in June 2018, Graham DL and Alan Chesterman question whether addition of instrumentation, which we use a lot for monitoring and controlling processes, really makes things safer. More significantly, they ask the same question about pressure relief, emergency shutdown and fire detection systems that we add specifically for safety. They acknowledge that eliminating everything is not practical, but changing our mindset so that we really think about why we need things could result in systems that are inherently safer. The late great safety guru Trevor Kletz encouraged us to start thinking about inherent safety over 40 years ago. In this article published in LPB in June 1983, he described the basic concepts. For those not familiar with Trevor Kletz's work, he had a rare skill of being able to explain ideas in very simple and clear ways. As his ideas about inherent safety developed, he proposed the following 3 statements to explain how it could be used in practice. The first was, what you don't have can't leak. Why do you need that hazardous substance or condition? Could you achieve the same outcomes with safer alternatives? Could you install less of it? In lots of cases, it's not possible to eliminate all the hazards, so we need to be prepared for situations where control is lost. In this case, if people are not near the hazard, they cannot be harmed. Instead of locating your office block near to a hazardous part of the process, move it to another part of the site. The last one I would say is particularly interesting. We can see the world is getting more complex, and I guess we all have concerns. Trevor highlighted that it becomes very difficult to understand complex systems or predict how they're going to work. This means we can't see if it is safe or not. One of the biggest ironies is that the increased focus on safety in recent decades has resulted in us adding more things to keep people safe, and these have added greatly to the overall complexity of our systems. Now this year, 2024, marked the 50th anniversary of the Flixborough disaster. This happened at a chemical facility in North Lincolnshire in England. Most analyses of the accident tend to focus on why the pipework joining 2 reactors failed, because this was the event that led to a large release of flammable material. The subsequent explosion killed 28 people and injured another 36. Trevor Kletz followed another line of inquiry. He asked, why was there so much hazardous material in the first place? After all, if there'd been less, there would have been less to escape. The explosion may have been smaller or less energetic, and fewer people would have been harmed. He concluded that the system design resulted in a very inefficient reaction. This meant a higher inventory of raw materials had to be passed through the reactors, and so those reactors and the associated pipework had to be much larger. If the reaction had been more efficient, the size of the plant could have been reduced. The amount of material to leak if the pipework or reactor failed would have been much less. Whilst our aim must always be to prevent accidents, we have to acknowledge that there are always hazards and that prevention is never 100% reliable. The sad reality is that when accidents occur, people die who did not need to be anywhere near the source of the hazard. In particular, office workers who may not even realise they were in danger. By far the best strategy is to lay out your site so that people can work as far away from possible from the hazards. I mean, buildings can be protected against those hazards, but this is expensive and less effective control. And it can have knock-on effects. For example, you can block up the windows to protect against explosions, but this makes a big difference to the working environment inside the building. In this paper published in LPB in June 2024, Andrea Longley and Ken Patterson describe a number of accidents where people died because they were in a building near to a hazard. Flixborough is one of those, but we also have PP Texas City, where people died inside a temporary building that was completely destroyed by an explosion. Also, we had an accident in 1992 at a site owned by Hickson and Welsh. In this case, a jet fire impinged on an office block, killing 5 people inside. This is arguably one of the most overlooked aspects of inherent safety. We are often somehow unreasonably impressed by complex items and favour them over the simpler alternatives. But simpler systems have fewer points of failure. They are easy to operate, and this means people need less training and they are less likely to make mistakes when interacting with those items. There is less to monitor, and it's easy to tell if everything is working okay or if something is going wrong. And if a fault does occur, the possibility of it cascading further to other parts of the system is much less. In this paper from LPB 2001, Neil Gove explains how the increased use of programmable electronic systems has resulted in complex control systems being used. They can be quite cheap and easy to implement, but it becomes very difficult to fully understand how they work, and more importantly, how can they fail. This is particularly concerning when they're installed to carry out a safety function, because it's really difficult to know if they will actually work when we really need them to. The principles of inherent safety can be applied to any industrial activity at any phase in its life cycle. But, the best time to consider it is at an initial concept, when that's being developed for a plant or a site or some sort of activity. Decisions made at this early stage will influence everything that follows. Unfortunately, we often miss that opportunity to ask, is a hazard really required? Do people really need to be nearby? And could the solution be simplified? Encouraging designers to consider the opportunities is another way of developing an inherently safer solution. Instead of them just following previous conventions, ask them to research, are there alternatives? Once plant or equipment is operational, the opportunities to fully implement inherent safety are reduced, but it doesn't mean it can't be considered. Reducing the quantity of hazardous material being stored, for example, operating at lower pressures or temperatures, and keeping people away as much as possible should always be considered. And when it comes to planning maintenance, make sure that the equipment is properly isolated and all hazards and materials are removed. Try to plan work so that adjacent hazards are also eliminated. Keep the number of people on site to a minimum, especially during the most hazardous times. Experience shows we have disproportionate number of accidents when restarting plant and equipment after it's being maintained. I hope you found this very brief introduction to inherent safety interesting, and I would encourage you to visit the LPB website, where you can find some free downloads, and a full archive of the publication freely available to IChemE members and subscribers to the LPB. Thank you.